Hi, we're back, and this is page 5 of your graphs of exponential and log functions. So, like we've been doing, we're doing the exponential and then we're doing the log, and we're sharing the same graph because they're inverses of each other. So now we need to use the properties of inverse functions to graph the given function and its inverse. So the easy one, I'm going to start with this one. I'm going to go to y equals, and then let's plug that in. And you have two options here. One, you can just do that as a fraction. When you use the fraction on the y equals, your table will come back with fractions. Now, if you use that division, so 1 divided by 2, and you still raise to that exponent, then your table right there will give you the answers as decimals. So I don't know, since we're plotting the points, it's just easier to me to see the points as decimal places. I don't know, but it's just a matter of preference. Now you know how the y equals works. So I'm going to use I'm going to use blue to graph the original function. So I cannot graph the 32, the 16, but I can go ahead and graph -3 and 8. -2, 4, -1, 2, 0, 1, 1.5, 1.25, and then it's clear that we're approaching 0 right there. And this is f of x. Now, I know the exponential and the logs, they're inverses of each other. And remember, the base is always the base. So for me to write the inverse of this function right here, I know this is an exponential function, so the inverse of that function is going to be log of something. And I said the base is always the base, so since this base right here is 1/2, this base right here will also be 1/2. So handy dandy calculator, we're going to go math, we're going to go log base, and then you can choose to put 0.5 right there, or you can do the fraction. Either way, they're all going to be the same. And remember from the previous videos, we cannot take negative, the log of negative arguments right there. That's why you have undefined right there. So the first one I can plot is 1, 0. 2, -1, 3, about 1.5, 4, -2. And I'm just going to skip to another pretty one because we kind of already have an idea what it's going to look like. So, and thinking about how inverses work, we know if f of x is approaching 0 right there, or is approaching the x-axis, I know its inverse, it's going to approach the y-axis right there. So, and this is the inverse of f of x. So I'm going to answer domain and range. I'm going to answer all these questions for both functions. So domain is going to be the same for both of them. And they're both from -infinity to +infinity. And if you want to write all real numbers, that's fine too. Range, they're going to be the same. Also from 0. Are they the same? No, they're not. So let's rewind here. Sorry about that. White out, big time. Okay, I got carried away right here. So here we have the domain for f of x, and it's all the x. But notice how the domain right here on the red it does not cross the negative and it doesn't touch the y-axis right there. So your domain will go from 0 to positive infinity right there. So I should have caught that. So the domain and range, they flip because of the x and y, they flip. So range for the blue function is everything from 0 all the way up to positive infinity. But then on the red function, notice that the y is everything from negative to positive y values. So everything from negative infinity to positive infinity. Okay, so asymptote right here on the blue function, or the original, the exponential function, we have a horizontal asymptote right there at y equals 0. And then its inverse will have a vertical asymptote right there at x equals 0, right there. So x-intercept on the exponential function, we don't have one. For its inverse, we do have one, and it's that right there. That's the x-intercept. 0, 1, 0. So y-intercept right here, we have that right there, 0, 1. And for its inverse, or the log function, we don't have a y-intercept. It approaches the y-axis though. So the exponential is decreasing all the way, so from negative infinity to positive infinity. And also the log is also decreasing from 0, not including 0, but from almost close to 0 and all the way up to positive infinity right there. So the next one, handy dandy calculator there. I just need to change the base here to base 3. And if you're in doubt of what your graph should look like, just take a look at it. Okay. Now, it's inverse. So the base is always the base. Since the base here for this log function is 3, the base for its inverse will be 3, n raised to the power of x. So I can tell that over here is approaching 0. Okay, this one is in red is the inverse function. And this one in blue is f of x, is the original function. So I'm going to go ahead, instead of doing both at the same time, I'm just going to do all for the original function in blue, and then I'm going to do all for the red function, or its inverse right there in red. It's going to be easier that way. Okay, so domain right here, it's everything from 0 to positive infinity. Range is everything from negative infinity to positive infinity. Vertical asymptote right there because it's approaching the y-axis, so vertical asymptote at x equals 0. X-intercept, yep, right there, X-intercept at 1, 0. Y-intercept, none. it's increasing. It's increasing everywhere, so almost everywhere, but it does not cross the zero mark. So it's everything from 0 to positive infinity. So doing all of those for its inverse. So domain is everything on the x, so from negative infinity to positive infinity. Range, it doesn't cross into the negative portion of the y values right there, so it's everything above 0. So it starts at 0 and it goes all the way up to positive infinity. There's a horizontal asymptote right at when y equals 0, x-intercept none, y-intercept it's right there. So at 0, 1, it is also increasing, but it's increasing everywhere from negative infinity to positive infinity. Okay, so one more. This one is 5. So it's going to be approaching 0 right there, and then 0, 1, 1, 5, and I can even plot the 225 right there, but I know it's looking like this. And this is f of x. The base is always the base, and I know exponential and logs are inverses. So log base 5, because this is the base, so log base 5 right there. And I cannot take the log of a negative number. So 1, 0, 5, 1, and then it's going to be 25, 2. It should be a little more smooth right there. So this is that's the inverse of the exponential function right there. Okay, off we go. Domain, it's all real numbers for the original function. Now we're doing the exponential function first. So all real numbers from negative infinity to positive infinity. Range is everything starting at 0 and going up to positive infinity. Asymptote is horizontal asymptote right at y equals 0. X-intercept none, y-intercept right there at 0, 1. Increasing for this one, where from negative infinity to positive infinity. Now for its inverse, domain is everything, but it starts at 0, from 0 to positive infinity, excluding 0. So range is everything from negative infinity to positive infinity. The asymptote is vertical asymptote right at x equals 0. X-intercept, yes, right there as 1, 0. Y-intercept, none. Also increasing from starting at 0 to positive infinity. Can we do more? Yep, we are doing good in time. Okay. Oh, transformations. Aha. Okay, so here we have. So we know h will tell you whether or not the function is going to go where it's going. But h will tell you side to side, right or left. K is telling you up or down. So if it's plus k, it goes up. If it's minus k, it goes down. A is the initial value, and the base is always the base. B is for the base. If A is negative, that's going to be a reflection over the x-axis. If your exponent here, if you have a negative right there, that's going to indicate reflection across the y-axis. So it goes with everything that we're used to. This one is a little different because it's on the exponent this time, exponential, exponent. Okay, but the rules for A, H, and K are still the same. They still apply. The only thing that you just need to remember is if the negative is right there, then it's going to be a reflection across the y-axis. Okay, so when I look at this graph compared to the parent function, I can tell that it's been reflected over the y-axis. And it also went up 1 because otherwise it would have the y-intercept right there at 0, 1. But it's at 0, 2, so it went up 1. This second graph right here, if the y-intercept was supposed to be here, it went down 2, but no other transformations. This other one, um, it should be here, but it's there. So we went there. Okay, so left 1. This one is a reflection. It's still where it should be, but it's a reflection. It reflects over the x-axis. Anything else? No, no shift. Okay, so we have the description on the graphs. We just need to match with the functions up there. So when I look at this, I have a +1 right here. That would be h. So +1 means it went left 1. So the one that is going left 1 is this one. So this is going to be a ex plus 1. Let's just write the whole thing, g of x. Okay. The second one, I have the negative right in front of e. That will be your a would be -1. So it's a reflection over the x-axis. The only one with the reflection over the x-axis is this one right here. So this one is b. The next one I have -2, and that's the k value. So the -2 is indicating the graph went down 2. So that belongs to this one. Last one, I have this one, and that's what I was telling you about. If the negative is right there, that indicates reflection across the y-axis. And then this is k is +1, so it went up 1. The last one left is this one. I'm going to start a new video for the next question. And the last page. Bye.